Hello everyone, this is Pramiti Borba. Today I am going to present the paper The Past, Present and Future of Software Evolution by Michael W. Godfrey and Daniel M. German. Let's first get introduced with the authors. Michael W. Godfrey is a professor of computer science department in University of Waterloo, Canada. His age index is 42 and the number of citations is 7069. Daniel M. German is also a professor of computer science department in University of Victoria. His age index is 48 and citation is 8219. The paper was first published in the 4th IEEE International Conference on Software Maintenance in September 2008. It was cited 159 times. This paper addressed several research questions like how software evolution relates and differ from software maintenance, how software evolution differs from other kinds of evolution, and why software systems needs to adapt changing environment, and finally, what are the future of software evolution for research. The motivation of this paper is to first compare software maintenance with software evolution, then identifying the relationship and differences between software evolution and biological evolution, and lastly, addressing the challenging terms of software evolution. Though the terms software evolution and software maintenance widely used interchangeably, there are some differences between them. Software maintenance refers to keeping existing system running without changing the design, where software evolution is the practice of software maintenance that requires several changes in design over time by fixing bugs, adding new features, improving internal design so that the system is easier to manage and change. The nature of software maintenance is preserving and fixing of faulty design, but the software evolution involves innovation and new design from the old design. The goal of software maintenance is to identify factors that might affect running the software smoothly. There are four basic categories of software maintenance. The first category is corrective maintenance, where the change involves fixing bugs in the codebase and to enhance the performance of the system. Adaptive maintenance allows a system to run within a new platform. The third category is perfective maintenance, which perform enhancements to make the system better by adding new features, boosting performance, or improving system documentation. Lastly, preventing maintenance requires modification of the system to facilitate future maintenance and evolution. There are some observations, such as Lemons law of evolution, that contains 8 laws of evolution. The laws concerned with E-type systems, which is a system that is produced by a team of a company to solve real-world problems for human users. The first law is the continuing change. If the system is not continuously adapted to meeting new needs, it will become less satisfying to its user over time. Second law, increasing complexity, indicates that a system will become progressively more complex if work is not done to explicitly reduce the complexity. Third law is self-regulation. The process of software evolution is self-regulating with the distribution of the products and process artifacts. The conversation of organizational stability law states that the average amount of work that goes into each release is about the same. Fifth law, conservation of formality, is the amount of new content in each successive release of a system tends to stay constant or decrease over time. Continuous growth law states that the amount of functionality is in a system will increase over time in order to please its user. Declining quality law indicates that the quality of a system will decline over time if the design is not carefully maintained. Finally, the feedback system states that the successful evolving of a software system consists of multiple loop, multi-agent, multi-level feedback system. The paper explained the staged model of maintenance and evolution, which was presented by Benith and Razlik. Here we can see that the model consists of 4 stages. In the initial development stage, the first delivered version is produced. Simple changes are performed in the active evolution stage. It is also possible to perform major changes in this stage. Cost and risk are also increased compared to the previous stage. The servicing stage requires maintenance. Here, the costs and risks are higher than before. The final stage, phase out, indicates that it has been decided to replace and eliminate the system entirely, as there is a newer solution waiting. So the system is shut down. In the next slide, we will see the comparison between biological evolution and software evolution. Biological evolution only contains inheritable change over time with individuals such as species without planning. On the other hand, software evolution is designed by humans with proper planning with specific goals. One cannot change biological evolution as needed, but it is possible to change software evolution as required to obtain desired outcomes. In the next couple of slides, we will be observing some challenges and road ahead of software evolution. In model building and empirical studies, the challenge is how do we proceed? The first problem is that even from the same domain, the software systems tends to be different. The second problem is accessibility. Though many open source systems can be studied freely, most of the commercial software are still created in closed source. The third problem is it is hard to understand how the evolution is taking place. The next challenge is can we create general laws of software evolution by studying open source system? There are some restrictions on proprietary software such as NDS that limits the details that can be published. This causes two fundamental problems such as empirical studies cannot be easily extended and so much details is left out of the study. Here the challenge is can we anticipate how a system will respond to environment pressure? To answer this question, it is necessary to plan in advance and continue to evolve in pre-planned manner. The system design should be adapted and must satisfy the user needs. The development team needs to understand its current and future deployment environment. The next challenge is how to improve our understanding of how systems evolve. The historic artifacts should be preserved. One challenge here is that how can the developers help to create a collective memory for their projects with a minimum of effort, where the role indicates that documenting the system behaviors and the evolution of the system. The challenge here is how can we better understand systems, as most of the component and service oriented software development is under control of other organizations. Evolution is dependent on the evolution of other systems. It is often challenging to provide better models for such systems. Finally, the challenge is how we can understand the economics of and risk. It requires to make decisions that balance economics and technical risk. There are also some cultural gap between professional developer and the researcher. From this paper, we have learned that software evolution and software maintenance are two separate terms with their own meaning. It encompasses both planned and unplanned manner, where how to model is still in learning phase. These are the references that I have used for this presentation. Thank you all.